Okay, next, we're going to do obesity for these variables, weight and height. Just explore these two variables first. Any missing values, any out of range values, any typos, these kind of things. Okay, so let's start. Analyze, descriptive statistics, and explore. Explore, earlier used frequency. Explore gives you more information about the data itself. All right, bring the variable, height and weight. Select this plots button, plots. Ask for histogram and also normality plot. You want to see whether data is distributed normally. Some of the analysis later, like regression analysis, will require this. So just showing you how to get these values, okay? Continue. And just click OK. Right. So mean height, 158. And the standard deviation is 9.1. And the skewness cutoff is right. Skewness is 0.2, very close to 0. Can assume the data to be symmetrical. The weight, mean is 71 kg. Standard deviation, about 18 kg. And the skewness, slightly more than 1, a bit skewed to the right. Minimum, maximum, 36 kg and 156. Your height, minimum, maximum, 125 and 182. We are looking for possible extreme values, outer range values, or typos, whatever it is. And the distribution itself, we look at this tensor normality. Both the p-values are less than 0.05. So height and weight are not distributed normal. Histogram, we can see normally this is quite okay, except for some people are very low, very short. To remove this, it may become better. In the box plot, we can see the case number 1. The 1 is case number 1 and case number 71. So these two people are low in the particular values of height, right? So case number, maybe a good next one. This is weight. Look at one guy sitting right here, more than 150 kg. That is the reason why the data is skewed to the right. Let's see now. That's case number 55. Case number 55 is an extreme asterisk sign, extreme value. What's the value like? About 155, about 155 kg. Is it possible? 155 kg? Can it be, it's not accurate? Is it possible it's not accurate?
Yes.
The person typed the number, typed wrongly.
Yes.
Instead of 555, the person typed 155. Is it possible?
Yes.
Okay, we don't know, right? Let's check this case number 55. So go to data, case number 55. Now, if yours different, just follow the number. You follow this number. Mine is 55. So case number 55, 156 kg. Do you think it's a mistake? Do you think it's a mistake? Second
Yes.
variable, weight perception. This person said, lebih berat, right?
Yes.
The person acknowledges she's heavy, he or she. Right? She, 43 years old, housewife. She agrees that she's overweight. And ask her what's the ideal weight, her ideal weight. Ideal weight of 100. According to her, the ideal weight was 100. So do you think she made a mistake in entering this value 156?
No.
No.
Right, most likely not. Right? The person said ideal weight 55, and most likely she made a mistake here. Right? So I think she is genuinely about 156 kg. So leave it. Okay? So when you do the obesity, this person will be in the obese, very high obese level. All right. So always look at your variables first. Don't simply go and analyze it. Some value become extreme, wondering why. So we know that case number, whatever number is now, you're going to affect, right? 156, extreme value compared to others. But she herself admitted she's the heavier side, and she herself said that ideal weight must be around 100. So it's possible. Okay, let's compute BMI now. Go to transform, compute variable, type here BMI. In the numerical expression, double click weight, don't type, okay? Double click weight, it goes here. Divide by, in bracket, double click height times height. So it's weight over height squared. You can have different form of the expression, but this is a straightforward expression. That's all. Click OK. So in a data editor, you go to the last column in a data editor. Right. Okay, that's a BMI. Is there a mistake we made here?
The height was in centimeters.
Height was in centimeter, right? So shall we change the height to centimeter first?
Yeah.
All right. So that's height variable. Okay, this height, I'm going to change this centimeter first. So transform, compute, or keep it this way. If I use this formula, what must I do here? What other thing must I do here? Times by 100?
Divide it by 100.
Where are the times?
Divide.
So you want to divide here, okay, fine, all right. Divide by 100 times that, and divide this by 100. All right. So telling the height, divide 100 meters times height, divide this, right? Okay. Okay. Okay, let's look at the last column. All right, that's a BMI. Right, so those doing the research on BMI, so that's your BMI values. You can describe this if you want to. Describing this, go back to analysis again, analyze, descriptive, explore. Just now we explored height and weight. Let's remove these two and bring the last one. That's BMI. Let's see how the BMI variable looks like. Click OK. That's a mean BMI value. Okay, what's the median value? What's the median BMI?
27.3.
27, right. The median BMI is 27. What does it mean? Median value 27 means what?
Majority are overweight.
Majority is mode, not median. Majority is mode.
The middle value is 27.
What do you mean by middle value? Middle value 27 means what?
We arrange the number from lowest to highest, and then we cut like the smallest and the biggest until we reach the center value.
So what is telling us? What is it telling us? What is number telling us? Middle means at least 50% must be above, right? Isn't it?
Yeah.
At least 50% of the respondents' BMI is more than 27. The median value 27 means at least 50% of the respondents' BMI is more than 27. So what does it mean in practice?
They are overweight.
27 means what? Is it overweight?
Yeah, above 25 is overweight.
Yeah, at least 50% are overweight. At least. You are telling 25, right? You're telling 25 is overweight, right?
Yes.
So I'm telling this, the median selling 27. So 27 above is already 50%. The 25 to 27, there could be more people inside the particular interval as well. So at least 50% are overweight. This BMI group, obesity group, is it important to you? This
Yes.
feature, is it important to you?
Yes.
Yes. What about this? How is this value important? What is this value telling you? This 95% confidence interval, this estimation, based on sample of 180, what can you say about the entire population? So this is your 95% CI. We say we are 95% confident the mean BMI in the population, that means all the people in the location, is between 27 to 29. 27 to 29. What's the normal BMI? What's the normal BMI? It was obesity group, normal BMI.
For Asian population is below 23.
So does 23 fall inside this interval?
No.
No. So straight away we can say 95% CI, 27 to 29, that indicates that people are quite obese, right?
Yes.
This says at least 50% in the sample are overweight obese. This says you're confident 95%, the mean BMI is between 27 and 29. The value 23 or even 25 doesn't fall inside. So generally they are on the obese side. Skewness value 1.6. You can see the data is slightly skewed. Look at the minimum maximum. Minimum is 15. Minimum BMI is 15. Means what?
Underweight.
There's a lot of information inside here. Otherwise, why SPSS gives all the different values? 15 underweight. There are some underweight. 66.
Very obese.
Which obese category? What?
Not
Obese?
sure.
How many levels do you have in obese? It's obesity group. You must know this, right?
Yes, there's 3 levels, Prof.
3 levels. So this guy will fall which level?
Class 3.
3. What's 1? Class 1?
Class 1 is with from 25 to 30, 29.
29. Next one?
Then 30 to 39.
39.
Then it will be class 3.
39. No, but that's 66, right? Okay. Let's see the graph, that box plot. The guy saying 55, case number 55, so high. We suspected maybe the person didn't typo, whatever it is. But she mentioned that ideally hers must be 100. She's 156. Most likely, what she is, right? Because the questionnaire was administered online. Nobody saw her, and she was obese or not, we don't know. But based on some other factors given, I think most likely she is very obese, right? Okay. I'm going to report the actual BMI or the BMI category. Actual BMI or BMI category?
The category.
Category. Okay, how many levels do we have? BMI category, how many levels?
5.
5 levels. Okay, BMI category. So what are the levels we have?
So the first one we want to start is underweight.
Underweight. Okay, underweight. What's the definition of underweight?
Below 18.5
Below
BMI.
18.5. Okay. Next one. Normal weight.
Normal. Between 18.5 to 22.9.
22.9. Then
And then obese category 1.
very obese, not overweight.
Overweight, so sorry.
Yeah, you should know. What's that? Overweight.
Above 25.
Overweight. More than 25?
Yeah.
What happened between 22.9 and 25? Yeah, what's the overweight category? Normal weight 18.5 to 22.9. After that,
Overweight is 23 to 25.
23.25. Next. Who are the members in this group, obesity group?
Obese class 1.
Obese class 1.
Yeah.
Right. Okay,
They-
obese. Yeah.
This is 25 to 29.9
25.
to 29.9.
25 already inside here.
So overweight will be 24.9.
This 24.9, is it?
Yes.
24.9. Okay. So this will be 25 to
25 to 29.9, sorry.
29. Next one. Obese 2.
Yeah, so obese type 2 is
Hey, this group should have done enough homework by now, right?
it's just more than 30, sir.
Just more than 30 obese 2, right?
Yeah, just more than 30.
Okay, more than 30. Right. So your name, underweight, normal, overweight, obese 1, obese 2. Later, not enough. Now, it is from 25 to 29. This one median was 27, right?
Yeah.
So majority will be falling in these two groups, right? About 50% will fall inside here, right?
Yes.
Yes.
Okay, so we don't know. So let's categorize it. So we're going to categorize the BMI into BMI categories. So go to transform. Okay, transform. Recode into different variable. Recode into different variable. This asking input and output variable. Input is BMI is created just now. Now say BMI arrow question mark, with BMI change to what? So the output variable name, let's say we type BMI cat, BMI dot cat, no space in between. You can give any other variables up to you. I just call it BMI cat. You can put the obese category or whatever it is. And click change. When you click change, this question mark will change to BMI cat. Now you're telling SPSS, convert the BMI into BMI cat. Next, what are the old and new values? So we need these values. Old and new values. Okay, first one. Underweight. Underweight, lowest through, from the lowest through, this 18.5 and below, right? Below 18.5, right? So I put there 18.49. 18.5 will go inside here already. You want few decimals, no harm. When come to 18.5, will be inside here. Doesn't matter how many nines you put. So this will be taken as value 1. So all the BMI values from lowest 15, 16, 17, 18 until 18.499 will be grouped into this value. Like the 16 here. The 16 will become 1 because this below that value. Next level, range. So look at the next one, 18.5 to 22.9. So 18.5 inclusive to 22.9 inclusive. Okay, that will be number 2. Example 22, okay, this value will go into number 2. Next, because these values are decimals, when I take here to 29 and 23, 22.91 won't be included in any categories. So next one, range, I'll start from 22.23 goes inside there, right? Hold on, then make it more decimals here. 23 goes next into. Right, 18.5 inclusive through 22.999, not reaching 23 yet. Next 23, starting until 24.89. That'll be number 3. Next one, inclusive 25 to 29 just to make a continuum between groups, that's all. So there are still values beyond 29.9, right? Okay, and the last group, what's the last group?
More than 30 BMI.
Can I say all other values? Or do you have all these? All the other values must be here, right?
Yes.
All right. They define all there, and then we go ahead with that, right? From this value, range value through the highest. So 30, is it in the obese 1 or obese 2? 30.
Obese 2.
Obese 2. That means must be more than equals, right?
Yes.
Right. So from 130 and above is value 5. All right. You can read, are they mutually exclusive? Any overlap? Right? So this until 18.9 here, the next decimal will go here until here, the next decimal will go here until here, right? Okay, they are mutually exclusive and all the values be covered. Continue and click OK. So look at the results. Look at this 1, which is this group. 2 is this group. 3 is this group. 4, obese 1 is this group. Obese 2. Okay, number 5 was the 30. Any questions?
Questions?
Any questions on this?
No, Prof.
No. Now you're going to label this. Go to variable view. Last variable created. The variable view. Values. Values. So that we understand. We label this so that we know what it is. Give the file to someone else, they know what it is. Otherwise, they wouldn't know what's 1, 2, 3, 4, 5. So what's 1? Underweight. 2. Normal weight. 3. Overweight. 4. Obese 1. And 5. Obese 2. The decimal doesn't matter, right? Okay. Look at the variable view. So this one is obese, normal weight, overweight, and so on. Okay, next, let's check the frequency of this. How many in each group? How many in each, right, obesity category? Could analyze, descriptive. Now, is this variable quantitative or qualitative? BMI.
Quantitative.
BMI cat?
Qualitative.
Qualitative. So just now quantitative, mean and standard deviation. Qualitative will be frequency and percentages. So analyze, descriptive, frequencies, reset, reset. So bring the last variable we created, BMI cat. That's all. We want to know frequency table. Click OK. Look at the output. Okay, this is a distribution. Are you okay?
Yes, Prof.
Yes,
All
Prof.
right. So you're going to type, let's say, BMI category. You're also going to create a table, insert a table, and put the values in. So this is BMI level, obesity, right? Or whatever name you want to give, it's up to you, right? Obesity. And here, frequency and percentages. All right. So fill it up. So how many percent are obese? How many percent are underweight? How many percent are underweight?
1.1.
1.1.
1.1%. Okay. 1 point, how many number? 2, right?
2.
2 or 1.1%. Underweight, but 2,
30,
30%,
bracket 16.7.
1,
15
10%,
in bracket 8.3%. Then 74 and 41.1%.
1.1%,
Then 59 bracket 32.8%.
32.8. All right. Okay, that's how your table is going to look like. After that, you go in discussion. So don't assume that people know how to calculate BMI. Okay, your obesity, how do you calculate this? BMI, I mean, write more detail, was calculated based on weight and height, and later BMI values and categorize. Right? In fact, here itself you can say that based and calculated with height squared, or you can put the weight over height, weight in kg over height square, right? Whatever you want to write here. The mean BMI value was whatever value here, and the median value was whatever. And then what does it mean? Based on BMI alone, right? Just explain. Next, the BMI values were then categorized into whatever categories, the results shown in table 2. So based on table 2, what do you see? Is obesity a problem here?
Yes.
Yes.
So what can I say? Between, can I combine these two to make it, how many percent is this?
73.9.
Right, in the sample, total how many? 1, 3, 3,
133.
right? 1, 3, 3. How many percent is this?
73.9.
73.9% of the respondents in the sample. Of the respondents either above obese, right? Above obese. Right. Okay, what's your objective? This group, what's your objective?
Our main objective is to see if there's association of mental health and obesity.
Oh, mental health and obesity, yeah.
Yeah.
Anything else?
And then we will just calculate the prevalence of obesity in the B40 community.
Number 1, prevalence of obesity first, right? Prevalence of obesity in this group. So what's your finding for this now? You want to know prevalence of obesity. What's the finding? Is this your finding?
Yeah.
Right? I'm only taking the obese. When I take the overweight, we'll add on some more, right?
Yeah.
That's your answer will come from here. So that's my objective number 1. I need the table value. So based on this, I can see even obese, I'm talking about only obese 1, obese 2, then the prevalence of obesity is 73.9%. Your second objective, what's second objective?
Studying the association of mental health with obesity.
Before that, factors associated with obesity. That's your demographic characteristics. Otherwise, why have this, right?
Yeah.
We want to know who's more obese, right?
Yes.
The male or female? Is it by the ethnicity? That's what you want to know. Your second objective will be factors associated with obesity. This is demographic variable. Third one, just now what you said?
Mental health and obesity.
What association between mental health
And obesity.
and obesity. So for each one, we need some analysis, right?
Yeah.
First one's done. Okay, first one's done, get the table, right? So what's your table? Table name it. I say put table X. And based on table X, you answer this. For this, factors associated, we must do further analysis. Now, you have to compare the demographic characteristics, example, gender and obesity. How many variables? Let me bring this variable just beside the demographics so you can see better. Right, leave it here. Right. So we have demographic characteristics. Let me remove all these. All right. The BMI category, gender, bangsa, and so on. Now, between these two variables, what do you want to know? Between these two variables, what do you want to know? Come on, your obesity group and gender, what do you want to know?
Whether male or female is more prone to obesity.
Right. You want to know what's the association between gender and obesity. Is it true that more females are obese compared to males? Right? So
Yeah.
that's what comes into your objective number 2, factors associated. That means all these factors here must be tested against the particular outcome, which is obesity. Right. What analysis will you do for this, comparing these two?
chi-square.
Huh?
Chi-square.
Chi-square. Okay, let's do chi-square. Analyze, descriptive, cross-tab. Cross-tab. You can put BMI cat in the column, Jantina in the row. So you're crossing gender versus BMI cat. Put the statistics. Ask for chi-square. And cells. Ask for row percentage. Continue. And click OK. Okay, look at the results. Okay, that's the p-value of the test. Is it more than or less than 0.05?
No,
More than 0.05, therefore,
not
there's
significant.
no association between these two. Now, before I continue, the numbers here being small, right? Only 2 here, 30 here. Is it okay we combine these two together? These two together as obese? The sample size is very small. See, lot of zeros here, small numbers and zeros here. Shall we collapse these two together? These are obese, right?
Yes.
Yeah,
Right? That means you're going to say this is obese group. This overweight, 15, okay. What about these two? Underweight
combine of underweight and normal.
into this? Shall I combine this into this?
Yeah,
Yes.
All right. Because the numbers is very small. So let's go and do it. And still keep the original value. Just for this analysis sake, we're going to do that. Insert a variable. Copy and paste here. For there are different ways of doing it. Simpler way, okay? Right click. Ascending. You want to show numbers? Right. So this I'm going to combine with these two. All right. And the last 4 and 5 are going to combine together because they're already obese. 4 combined here. Right. So I change this to variable name. Variable name, obese. How many levels now? 3 levels. Okay, obese 3. Okay. So let's do the crosstab again. Take out this. Put the obese 3. And click OK. Now, only 3 levels here. So what's the p-value?
0.39.
Still more than 0.05. Therefore, no significant association between gender and obesity. Look at obese. Obese 1. Obese, right? Obese 1 is referred obese. 81% of the males and 72% of the females are obese. Not much a difference. That's why the p-value is more than 0.05. Right? If one value is very much lesser, supposing the female value is, as example, 52, 81, 42 could be a big difference, then the p-value would have been less than 0.05. So as it is, We say there's no significant association between gender. So how to present this? Go back to word file again. So that's your demographic table. So this title is, let's say, table Y, table 3, right? Table 3, association between demographic characteristics. Okay. So earlier it was demographic characteristics. So now association with demographic characteristics and obesity. So open up, insert further columns. Okay, this will be underweight, open normal weight, right? Normal weight. Next one, overweight and obese. So this will be your chi-square value, that is 36 chi-square. And there will be a p-value. Okay, chi-square and the p-value. So we're going to report this first one, gender. Okay, for gender, male, how many are normal weight?
3,
3, how many percent?
9.4%.
0.4%. Next,
Female is 29,
29,
19.6%.
6%.
Overweight 3,
3.
9.4.
Hey, what about other members in this group?
12, 8.1. 26, 81.3%. And then 107, 72.3%.
Okay, the chi-square value, this is a chi-square value, 1.882. And that's a p-value 0.390. So go to fill up the same thing for all the values. So this is objective number 2, factors associated with obesity. These factors are talking about demographic characteristics. We've done number 1. Number 1, you can see that it's not significant. Okay? Now, but even for other groups, example, those doing, which are the variables, mental health, anxiety, finally will be categorized into several levels. Again, you must compare all these against your levels of stress, all these levels of depression, anxiety, all the tests will be similar, right? All the groups, you must compare the demographic variables with the outcome. Otherwise, why study demographic? Who's most likely to be with the outcome of interest? We don't know yet. Okay, marital status. Any questions?
No questions.
Don't copy and paste this file. Don't just copy and paste here and say this is my results, okay? We fail you because that's not academic enough. So you must have edit your tables and write formally, right? In an academic exercise. Okay, let's do the next one. Must you do one by one? I can do all in one go. Must you do one by one or can do all in one go? Bangsa, tahap pendidikan, kerjaan, all can be done in one go. Not umur, umur is quantitative. Just click OK. Let's see which variable makes a difference. You already done, Jantina? Next, Bangsa. Does it make a difference?
Yes.
Is p-value less than 0.05?
Yes.
Now, that's one assumption in this chi-square test. The minimum expected count must be at least 1 for a sample size 100 and above. This count must be at least 1. Why is not? Because look at the Sabah. The number is very small, right?
Yes.
Yes.
What it suggests?
2.
What it suggests to do after this? This assumption is
Combining.
not met, the results not valid. Combine with? Shall we combine Melayu? Guys, cannot?
Yes.
Yes, but if we can't, suppose you can't, then what do you do? For this analysis, go to Bangsa, the Sabahan, don't include in this analysis. If we can't combine them. Are you with me?
Yep.
All right. But still, hold on, don't do anything yet because it's not numerical. The last table, okay. This waterfall, Bangsa, right? See, this value is still there, see? We don't want that. So what do you do? You convert this into numerical. You want to do that. It's a data entry. When you capture through Google form, whatever, it will be string variable. But some analysis require this to be numerical, like this. So in such situation, sometimes we convert this to string numerical variables. All right, Sabah. I'm going to put there 3. Malay, according to my order, okay? According to my order, I'm going to change them to numerical. So this code is 1. This is to drop the Sabahan from the analysis. But if you feel that Sabahan can be added to the Malay group, then go ahead. These 2. The Sabahan, I leave it blank. So what I've done is, I'm not including Sabahans in the analysis. This can be done if the variable is numerical. This numerical now. So here, what's 1? 1 is Indian, 2 is Malay. So changing numerical has one advantage. Where is it? Changing to numerical. So here I say, I can create another variable, let's say Bangsa 2. Just watch first, huh? So now I have only the Bangsa, only India and Malays only. Indians and Malays only in the sample. Let me do the analysis now. Bangsa, Jantina. Let me just do this first. This Bangsa 2 alone, compared to Bangsa just now. So Bangsa 2, only Indians and Malays. That p-value is significant. Just now, I took India, Melayu, Sabah. This variable was the variable was string variable, not numerical. I can't simply drop Sabah. I saw it significant, but the result's not valid. I have to drop Sabah, so I have to convert the variables to numerical. Sabah excluded. Now this counts 1.94 for a sample size of 100 and above. This must be at least 1.94. So now, significant, yes, valid. How do you explain this now? That means there is an association between ethnicity and obesity. How do you explain this? How do you explain this association? What's the objective? What's the objective here?
To find if there's a association between ethnicity and obesity.
Obesity. So you're going to fill up these values. What's the chi-square value here?
9.625.
Right. What's the p-value?
0.08.
That is
0.08.
0.8, right? There is a significant association between ethnicity and level of obesity. So who's more obese? Don't have mentioned everything. Look at the obese now. Who is more likely to be obese?
Malay.
Among the Malays, right? There is, or there was, a significant association between ethnicity and obesity. Ethnicity and obesity. How does it work? Among the Malays, 77.4% were obese compared to only 47.8% among the Indians. Just now for gender, I didn't say anything. Why? There's no significant difference. Right? Okay, there was no significant association between gender and obesity. But ethnicity, gender and obesity, now ethnicity, yes. So you're going to fill up all the tables. This will answer your objective number 2, factors associated with obesity. Are you okay?
Yes, Prof.
Right. So as you go on, say other variables, we also saw some very small numbers. Let's run all this again. Already done Bangsa, already changed to only 2 levels. Jantina, okay. Let's try education. It's done. Education and pekerjaan. All right. Again, is there a significant association? What's the p-value?
P-value is 0.6, more than 0.05.
More significant association. This count also okay. So report this like for gender and say there's no significant association. Look at this obesity, 76, 66, 66, about the same only. There's no difference between the levels of education. Next, occupation. Does it make a difference?
Yes, there's a
Yes.
significance.
Significant difference. But this count is less than 1, right?
Yep.
That means some counts are very small, like 0. Look at this count, right? 0. So what shall I do? Pelajar. This
Tidak.
pelajar, right? What shall I do with the pelajar?
Can we combine it with tidak bekerja?
Okay. So don't have to drop it, like Sabah just now dropped it, because I couldn't combine with the Malays. They're totally different. So now, for occupation, maybe we can, now this applies for all the groups, all the groups. The pelajar, okay, pelajar, we're going to convert to not working, tidak bekerja. Right, these 4 people. And there you go. Especially when it's significant, we must look into the minimum cell count. Here it's not significant, so I don't bother much. Just now I said significant, now I check. Okay, this value 2.33, samples are 180, is more than 1. Now, is it significant?
Yes.
Huh?
No, slightly
No.
over.
But just now, before I corrected it, there was a difference, right? Which one was that? Okay, Jan, right? Here it was significant, but the results not valid. So what I did, I took the plaza, put them under tidak bekerja. So now, after correcting it, there's no significant association, right? So even though it's 81, 73, 53, the level is not significant. But however, you can still say, even though not significant 5%, there is a significant association at 10% because sample size is small. That's why it's not significant yet. But looking at this now, who's more obese? Looking at this, who's more likely to be obese?
The bekerja.
Working.
Working people are more obese, followed by housewives and not working, right? Working people seem to be more obese. You can still conclude, even though the p-value is not significant, the result shows that 81% of those working, 73% of the housewives, and 53% of those not working are obese. Can still make a conclusion, right? Because marginally are very close to 0.3. The sample size rather small. Right. So complete the table and we'll answer that question. Age, I think, no need, right, for this. Anything else? So done 1 and 2 for you. This one must wait until we summarize the mental health. The anxiety, stress, and depression. Then I bring this into, so still same thing, we create a table like this, anxiety level, whatever level, let's say 1, 2, 3, 4, 5 levels, same table here, same demography, same analysis, fill it up. Then you know who's more likely to be obese or to be depressed, right? Can obesity go below here also? The next table, comparing, sorry, your level is what, comparing? Obesity and mental health, obesity and mental health. So you'll have only the third table, obesity and mental health. We'll fill it up later. So only one. Okay, obesity, how many levels do you have now?
Normal and obese. Normal weight and obese.
Normal weight. And then overweight, right?
Yeah, overweight and then obese.
Overweight and obese. So this will be association between obesity, let's say, and depression. Okay, depression here, let's say, mild, moderate, and severe. Later we'll see how many groups coming. Okay, there are 5 groups. Let's say just put 2 groups, 3 groups. Same thing, put the percentages, take the chi-square value, and discuss whether association between obesity and depression. Another table can be between obesity and anxiety and so on. Okay, once a group for anxiety has done it, so you can complete this. Any questions? Obesity group?
No question, Prof.
Okay. So I'm going to save this as obesity. All right. Who's next?
Next is quality of life.
Quality of life. Okay, take 5 minutes break. We'll continue with quality of life.